This lesson is on geometry's three undefined terms, but we're going to start a little more broadly with why study geometry at all. Then we're going to talk about the language of geometry, definitions in geometry, and then we're going to get to the three undefined terms: a point, a line, and when we talk about line, we're going to talk about other things about a line: a ray and a line segment, and then finally, what's a plane? And then the dimensions of the undefined terms. So the first question is, why study geometry at all? And the short answer is that geometry is really important. It's everywhere around us. If you've ever wanted to play sports, do art, if you wanted to figure out whether a rug is going to fit into a room, if you are doing construction work, we use geometry in all these things and many, many more as well. So understanding geometry helps us live our lives outside of school. Like all math, geometry has a language of its own. And in order to learn and understand geometry, we have to know these vocabulary and notations. This will allow us to read and write and quote-unquote speak the language of geometry. A definition is a statement of a meaning of a word. And most of the time, when we introduce a new term, we define it using terms we've already been defined. So for example, we say a triangle is a shape with three sides. But the first definition can't work this way because there aren't any words to define it. So imagine if we were trying to define triangle, but we didn't have the words sides or shape. We have to first define shape and sides. But if you keep going back far enough, eventually there's a term that is the first one, and there can't be a definition for that. Therefore, we have to have some undefined terms. And in geometry, we have three of these terms: point, line, and plane. So now let's go through, and even though they're undefined, what we can do is we can describe these ideas in language we all understand. Even though they're impossible to define exactly, we can give an idea using common language to understand what they mean. So a point is the basic building block of geometry. It tells an exact location. And for example, an ordered pair, x comma y, it tells an exact location of where that point of location is. A point is infinitely small. It can't be measured in any direction. It has no length, width, or depth. It doesn't actually exist. It simply is a point that tells about where a location is. It can't be drawn because it has no dimensions, but to represent it, we use a dot. And to show what it is, we use a dot with a capital letter, so for example, L. And you can get a reasonable idea of what a point is if you imagine making a dot on a piece of paper. But if you get a sharper and sharper pencil, so that dot gets smaller and smaller and smaller, you're starting to get closer to a point, because again, you can't actually really draw a point. If you had a pencil that was infinitely sharp, so it made the smallest dot it possibly could, an infinitely small dot that had no measures, that is really what a point is. Again, undefinable, but that gives you the idea of what a point is. What's a line? Well, a line is straight, it's made up of infinitely many points, and it's one-dimensional. That means it has a length, but no width or thickness or depth. And it extends forever in two directions, so it can't be measured. The answer is, how long is that line? The answer is always the same. It's infinitely long. And a line can't be drawn because it has only one dimension. It's like a point. It'd be infinitely small in the other dimensions. You wouldn't be able to see it. And it goes on and on forever. So to represent a line, we draw it with two arrows on the ends of the line like this. And that shows us that it goes on and on in both to the left and the right. And of course, this thing I've drawn actually does have thickness and even a tiny bit of depth, the ink on the paper. But just like a dot represents a point, this thing here represents a line. And there are three different ways to label lines. We want to refer to a line. We can refer to 2 points in a line, like for example, if it has A and B, we just call this line AB. We can use this notation with an actual line symbol over AB. Or we can use a scripted lowercase letter. In this case, I'll just use an L. So we can call that line L. Any of those ways is an appropriate way of referring to a particular line. Now lines can be broken up into smaller parts. So let's talk about one of those parts, which is a ray. It's part of a straight line that goes infinitely far in only one direction, but has an endpoint. That's called a ray. To represent a ray, we draw a line with an arrow going to one end, like that. And kind of like a line, we can label it in three ways very similarly. 2 points on the ray AB, we just call it ray AB. We can do AB with a symbol of a ray over it. Notice that has only one arrowhead on it going to the right, not to the left. So that's saying ray AB, not line AB. Or just like with a line, we can use a scripted lowercase letter, again like an L. The final part of a line is a line segment. And that has 2 endpoints on it. So, unlike a line or a ray, which go on infinitely long, a line goes on infinitely long in 2 directions, a ray in 1, a line segment is not infinitely long, so it can be measured. You can say this line segment is 7 inches long. To represent a line segment, we draw a line with no arrows because, again, it's not extending any direction, so we just draw it like that. So again, that's not a line, that's not a ray that I'm looking at, that's a line segment. And it can be labeled in this 3 similar ways to a line or ray. You can use 2 points, but they have to be the endpoints of the line segment, so A and B. You can use the terminology of an AB with an actual line segment over it, and if you look closely you can see that there are no arrow heads on that, so that's saying line segment AB, or you can use a scripted lowercase letter, again, like an L. That's line segment L. Okay, the final undefined term is a plane. And a plane is a perfectly flat surface extending infinitely far in all directions. So to imagine a plane, think of a plane of glass or a piece of paper or the desktop in front of you that is so big that you can't see the edges. It goes everywhere, goes in all directions infinitely far. So the figure to the left over here, it suggests the infinite nature of a plane. You can see that the arrows are going on forever in length and width. However, usually we just show a plane like the one on the right. And so a plane has length like a line segment. It goes it has infinite length, but it also has infinite width. But it does have no depth. So it still doesn't really exist. It's just a thought exercise because everything actually has to have 3 dimensions, and a plane only has 2, length and width. So finally, speaking of dimensions, let's talk about how many dimensions these, again, thought experiments, because they don't really exist, have. So there are 3 different dimensions, of course. We have length, height, and depth. And if there's something with 0 dimensions, it has none of those things, it's just a location, that's a point. If it has 1 dimension, so it has length but no height and no depth, that's a line. If it has 2 dimensions, so it has height and length but no depth, then it is a plane. And again, obviously we live in a 3-dimensional world, so nothing can have 0, 1, or 2 dimensions. So all these things, these undefined terms, don't really exist. They are thought experiments that help us start somewhere to build upon in geometry. And so if something has 3 dimensions, that's the real world. That's just the space we live in.